Good morning, Kali. Today we are going to solve exercise 338 of the book Fundamentals of Electrical Circuits Sadiku. In this exercise it asks me that by applying mesh analysis I must determine the current and zero the current that comes through here. Apply mesh analysis on the circuit in the figure and obtain Y0. OK. The first thing we're going to notice is that we have a current source inside two meshes. This is called super mesh. It is something similar to the super node. The super does not apply, is when there is a source of tension between two nodes. This is a current source between two meshes. Let's first apply a super mesh here. Well, before applying the super meshes, let's notice that there are four meshes. This would be mesh 1. Let's put it here. One current will circulate and one will mesh 2. I'm going to say that it's over here. Mesh 2, mesh 3, Y3, and mesh 4, IP4. Notice that I put independent meshes in each mesh. However, here this is going to be a single super mesh. But I have to identify the meshes because they are also independent. I explain. I'm going to do the super mesh here first, I'm going from here. Remember that the mesh, what we are doing a voltage analysis, the LVK red here is going to enter through the negative of the 24-volt voltage source. It would be minus 24. Well, it comes this way and it would be more than 4 times the current and 3 and we continue straight. We continue straight and we go to the other mesh that would be more than 3 times the current and 4 it comes this way plus 1. Time the current and 4 again once the current and 4 comes this way. Reaches this point more twice the current. As we are doing the super mesh it would be N4 minus N2, N4 minus N2. Remember that EHH resistance times current gives voltage. These are voltages. A voltage. This is another voltage. This other voltages in voltage EH. And let's go here more. I'm going to run a little. 2 times the current and 3 minus the current and 1. All this equal to 0. So, well, I'm going to put whatever has variables on one side of the equal and the constant on the other side. Well, I'm going 4 and 3. Notice that this goes the other way. 4 and 3 plus 3 times and 4 plus 2 and 4 plus 2 times and 4 minus 2 times and 2 plus 2 times and 3 minus 2 times. And 1, 2 and 3 twice and 1 equals 24. Now, if I add up all the ones I have and 1 all the ones I have and 2 all the ones they have and 3 all the ones they have. And 4 this is going to keep everything I have and 1 I only have a minus 2 and 1. Everything that has 2 there here I see the N2 minus 2 and 2. There's no more. Everything that has and 3 here there are 4. M plus 2 would be 6 and 3. Whatever you have there are 4. Here are 3 of and 4 plus 1 would be 4. Here there are 4. 3 plus 1 is 4. Plus 2, 6. Plus 6 and 4 equals 24. This is going to be my number 1 equation. Hey, okay. Now that's the super mesh. If we go to mesh I1, let's observe that current 1 comes here, comes here, comes here. When it reaches this point we observe that the current I1 is equal to minus 2 amperes. Negative. Remember that I usually do the favor of the hands of the clock. So the I1 comes this way, the I1 comes this way, the I1 comes this way. When it gets here we observe that the I1 is the same as 2 amperes. It would be minus 2 amperes, that is, the mesh current is minus 2 amperes. Remember that this is mesh current. It is not that 2 amperes are flowing through this resistance. It is not that the mesh current is minus 2 amperes. When we find the voltages here, it is a voltage minus one current minus the other, or sometimes it is added. Well, I already have EH. Current 1 I already know is minus 2 amps EH. We can replace this here and determine how much this equation is worth. Let's leave it here. Let's work on this one now. Here 1. We are going to work in mesh 2 or the current 2, which would be 1 times the current and 2 minus the current I1. Remember that I started with this one more. 2 times the current I2 minus the current and 4 we are here in mesh 2 plus the 9 volts plus 4 times the current and 2 is going to be equal to 0. If we solve it would be I2 minus and 1 plus 2 times and 2 minus 2 times and 4 plus 4 times and 2 equals minus 9. Hey! If I operate all of that, I'm going to get the I1. We are here. I'm going to put here except I1. There is only 1 and 1 sees it, and 2 there is 1 and 2 or 3 and 4 are 7 plus 7 and 2. Hey? And I know and 3, 9 and there are more 7 and 2. I think there is only 1. There are 2 and 4. There are 2. Here are 4 of the and 2. And here is the Y4. We did the and 1, we did the and 2. Now it is the and 3, there is no the and 4. There is only a minus 2 and 4 equals minus 9. This would be my equation. Hey? Well, we can call it 2. Now, we already made mesh 1. We already made mesh 2. We already made the super mesh. I already have the and 1. I'm going to come here. I'm going to grab this one here. And I'm going to replace the Y1. I'm going to put a brighter color on it. I'm going to replace the and 1 here. I'm going to bring this equation and put it here. So it would be minus 2 and 1, and the and 1 would be minus 2 by replacement because I already have it. So I'm going to make the equation 2 times minus 2 and 2 smaller. Plus 6 and 3 plus 6 and 4 equals 24. So this would be minus 2. For minus 2 it would be 2 times 244 positive goes to the other negative side. So here it would be minus 2 and 2. I'm putting this plus 6 and 3 plus 6 and 4 equals then 2 times 2 4, as they both have negative gives positive 4. If this is 4, I'm going to subtract that 4 to the other side and it gives me 20. So I already have an equation 3. I reduced this equation, so here there were 1234 variables left with 3 variables I have and 2 and 3 and 4. Now from this equation 2 I also have a current in 1 that I am also going to replace. I'm going to lock him up with another 1. This. I'm going to replace it with the and 1 and I'm going to put it down here, so minus and 1 is minus and 1 is minus 2. Plus 7 and 2 minus 2 and 4 to minus 9. So this is going to be 2. Positive. It will be 7 and 2 minus 2 and 4. Minus 2 and 4 equals minus 9 is this is going to be positive 2 when you pass it over there it would be minus 2. So it would be 10, 11 minus 11. Let's put minus 11 once minus 11. This would be an equation called 4. So let's notice that I'm going to rewrite the equation here. Here I have less than 1 and here I was wrong. Here I know, but I'm copying the one that wasn't. The ones I have to copy. It's 3 and 4. There is this one that is minus 2. And 2 yes, so that we don't get lost I am. What I'm doing is this. I'm rewriting it here. So I'm going to put minus 2 and 2. Minus 2 and 2 plus 6 and 3 plus 6 and 4 and equals 20. Hey, well, I have and 2 and 3 and 4. From this other equation I have it and I have 2 and 4 too. So I can put 7 and 2 plus 0 and 3, 9 minus 2 and 4 equals minus 11. I have 2 equations, 3 unknowns. There is a third equation missing that we can extract or always from a supermesh we can extract it from where the supermesh is. Let's precisely observe that we made a supermesh here. But from here we are going to get the equation that we are missing. How can we do it? Applying a Kirchhoff law. At this point let's remember that Kirchhoff's current law tells me that the currents entering a node are equal to those leaving. In other words, if 2 enter here, 1 comes out here, or if 1 enters here, 2 can come out. That is, at this point what goes in has to be equal to what goes out. So, at that point, I see that the current N3 of the mesh N3 comes like this, that is, what the AN3 enters there if the 4 amperes enter, 4 amperes, the N3 enters here, come in here and see that the 4 is coming. So, a clock in 4 then it comes out. I'm doing logic at this point 4 amps in, 3 in and 4 out. And 3 plus 4. Let's do it up here, EH, so that it can be seen then and 3 plus 4 amps. True, at that point N3 4 enters because the N3 comes here and reaches this point. Since this is an extreme, that is independent of another mesh, the current that passes through here, the same N3 is not, unlike this one that is between 2 meshes and since this one is only inside one mesh, because the N3 enters 4 amps comes in here. The eigenvalue of the current of this wire 4 is going to be equal to the current N4. Since we are working with meshes, it would be N3 minus N4 equal to minus 4. I did this, I passed it to the other side and I passed this on the other side so. N3 minus N4 equals minus 4. That is, here it would be 0, here it would be Y3, here it would be Y4 and here it would be minus 4. N3 minus N4 equals minus 4. N3 minus N4 equals minus 4. Perfect. That's what I'm going to put into MATLAB. From MATLAB I have the value of minus 2, 6 and minus 2 spaces 6 space 6 to 6670 minus 2. Semicolon 7 0 0 1 minus 1. A minus 1, and the solution would be 20 to 11 minus 4 20 11 minus 4 20 11 minus 4. Good. I confirm that everything is fine. And I verify that it is telling me that the current. And 2, let's remember that this equation is in terms of N2 and 3 and 4. So this would be N2 tells me that the N2 is minus 0.55, the N3 minus 0.425, and the N4 3.575. So N2 N12 minus 0. Well, I'm going to make it shorter for one thing. N2 is minus 0.55. En 310 minus 0.425, and the N4 and 3.575 amps. And the N1. Well, we already had it. We already have the N1, which was minus 2 amps. Okay. So the exercise asks me to determine the Y sub 0. The Y sub 0. Let's watch it go down. So the current I1 goes in the same direction as the Y sub 0. So how does it go in the same direction? Well, I say that the sub 0 is equal to Y1 minus the Y2. Because the Y2 goes in the opposite direction, then the Y sub 0 is the Y1 minus the Y2 and the Y1. We have it, which is minus 2 amps, and the N2 and the N2. I'm going down. I have it here, which is minus 0.55. What am I going to do in MATLAB? I already have those variables, that is, the solution variable, position 1 and 2, position 2 and position 3. Position 1 is current N2. Remember that here I put this equation that only has N2 and 3 and 4. It N1 as I already had it. Well, I didn't put it here. So what am I going to do? It is minus 2 amperes, which is the 1 and 1 we already have above, minus the solution. Position 1 would then be minus 2 amps minus the solution variable in position 1. A certain listener tells me that the current N sub 0 is minus 1.45. I'm going to put here the Y sub 0 is equal to minus 1.45. I like to teach with MATLAB because I know that later they will get more complex exercises like factorial circuits or more complex things. So to speed this up, right? Others will say no, because here it was already minus 2 amperes and this is minus 0.55. If it was less, it would be more. So negative 2 plus 0.55 would be minus 1.45, and that's it. But I like to teach that way because they become familiar with MATLAB. Well, this is